Hello everyone, my name is Silvio Ribeiro and I'm going to present this work, Scalable Detection of SQL Injection in Cyber-Physical Systems. It was developed in the Computer Network and Security Laboratory at the State University of Ceará. The authors of this paper is Michael Souza, me, Vanessa Carvalho, Lima, Francisco Conceição, and the Professor Rafael Gomes. So the presentation was divided into 6 parts. In the first one, I will introduce the context of this work, emphasizing the main problems and concepts and the approach we choose. So after this, I will show some related works, followed by our proposal, the architecture, and the main modules of the system. So the next part, the experiments, configurations, and environments. Finally, I will show the results and what information and conclusion we achieve. So in the industry of the future, we have a massive data sharing between heterogeneous devices. That communication often runs in cloud and edge environments. So this ecosystem is composed by cyber-physical systems, or CPS, and it has the potential to impact several aspects of our lives, especially in the 4.0 industry. In this context, there are many interconnected devices exchange information by storing and retrieving this data from SQL relational databases. In this way, some weakness can emerge, the unsafe access to information by users or devices in the network, and malicious devices connected to the networks that can run malicious programs. So SQL injection or SQLi can exploit these weaknesses, especially in unsafe queries and text files. SQL injection or SQLi, as I said before, is a malicious way to exploit back-formulated queries in databases. It looks for access to sensitive information by deceiving the request process. It's often operated by a human attacker, but it also can be executed by an infected CPS, who looks for access to an unauthorized database. In this case, it becomes a vector for this attack. In this way, a solution to detect SQL threats using low computation resources would be interesting considering the constrained requirements of the heterogeneous devices. So current solutions for SQL injection detection often executes AI techniques. We consider that these techniques do not fulfill the requirements of the limited scenario for CPS. The high computational cost of training and running AI models over a large volume of data can be a problem. We believe that AI techniques can be used in a restricted scenario where initial filters identify the most part of suspect strings before. In this way, we propose the SQLi that use regex regular expression as an initial filter. It looks for meeting the aspect of time processing and response, preventing more complex solutions from being run unnecessarily. So the SQLi features involve an API to provide the interconnection between CPSs and the environment, while this can be executed in the edge or cloud scenarios. The set of regex is flexible according to the profile of the services to be protected. That is, it can grow and the efficiency does not reduce. The regex must check when a malicious field tries to inject SQL in an input field or in an infected payload for transmission between 2 or more devices. These are some related works that meet some aspects of SQLi detection, but do not consider the use of regexes for SQL injection verification. Most of them propose the uses of AI techniques in a way we consider unnecessarily And our solution can also be a good initial filter for the same AI techniques and application, providing an efficient use of the computational resources. Our proposal looks to encompass different SQL injection threads, using the set of regexes according to the profile of the threads and services. It has three main modules: the APIs. The API allows the communication between devices and the application in cloud and edge environments. The analysis modules execute the set of regexes over the inputs provided by devices in the cloud environment. The regexes is stored in a regexDB, which manages the set of regexes, and it can grow to provide more security, enabling more protection by new regexes. So the new regexDB can be shared with the edge environment, so letting the updating process only in the cloud. So this is an overview of the main set of 8 regexes that we consider in our work, with the text SQL metacharacters, or and strings, logic operators, query strings, in the way that SQL injection threads are structured. So in the experiments, we consider a widely used dataset of strings that can be SQL injection or not. The dataset includes SQL injection and common text inputs in real-world text fields over the internet. We use several environments over the Huawei Cloud virtual machines to run this project. It includes the GCP, which provides a balance between resources like memory, network, and processing. The IMO, that is a machine optimized for memory, just for application that needs many calls for memory. The HCP, that provides high performance in parallel applications and infrastructure services. The KPG uses a QPeng processor that allows an economic baseline for services immigrating tasks. And finally, we test in a physical machine in the edge. This is a CPU Intel Core i5 processor, as memory of 8 gigabytes, DDR4, and SSD of 256 gigabytes. In addition, we compared this proposal with various machine learning solutions and evaluate the accuracy, recall, and precision. So this figure shows the average performance of every regex over the entire database for each environment. These 60 and 70 regexes are the slowest ones to process, and the QPeng machine has a generally slow performance. The physical machine is better for this task because of the delay time to access cloud environment. Also, we can see, besides the variation of time elapses between the regexes in a general way, the time remains low, meeting the requirements of cyber-physical system in smart environments or IoT in the context of 4.0 industry. In this context, in this graph, we can see that if the regex database grows, the updating time of the regexes set is maintained in an acceptable way. By this, we can simulate if the regex set grows, involve more regexes, and provide more security. We measure the SSKLI's efficiency to detect SKLI threats over these machine learning techniques. So we compared with the logistic regression, reinforced SVM, Navy Base, Decision Tree, and CNN. We also measured the metric for each case of detection in percent. The accuracy shows that the average correct SQLi threads over the entire results. The precision shows which positive values are really positive. That is, the capacity of the system to detect if a thread of the SQL injection is not a false positive. And finally, the recall that shows the correct identification including positive and negative values. That is, if a thread is really a thread or is a safe string, really a safe string. So by these results, we can see that our solution matches good comparing with these machine learning models. So finally, we propose a scalable way to detect threats of SQL injection attacks, considering the massive volume of the data generated and shared in large industrial parks or in any context of the 4.0 industry. The solution deals with the efficiency requirements for cyber-physical systems in smart environments, meeting the aspects of the limited computational resources. Also, the solution can be a good initial feature followed by robust machine learning models. So thank you for your attention and goodbye.